All right, so what we're looking at here is a motor start-stop control program in the PLC. We also have wired up to it a small DC motor with the current value sufficiently low enough that we can run it directly off of the discrete output, Y1. The program in the PLC really begins here with rung 16. We have a few other rungs here that are not of interest to us right now, but rung 16 is what's really controlling the status of the motor. Notice we have a couple of contacts that are linked to X inputs. One for a start push button, one for a stop push button. We also have a couple of contacts linked to C bits, C1 and C2. Notice the X1 and X2 have been named start normally open push button, stop normally open push button, and the bits C1 and C2 are labeled HMI start and HMI stop. So this is a motor start-stop system using hardwired switches to start and stop, as well as HMI virtual push buttons to start and stop. So here's how it works. If any contact is made here, if any coloring happens here, and these are colored as well, we'll get color all the way through to the Y1 coil. That in turn will color that Y1 contact, which seals in the logic and keeps the motor running. Notice how these are normally closed instructions, normally closed contacts in the PLC, which means that they will be in the colored state unless and until the respective bit gets set to a 1 by either the hardwired switch or the HMI. So if I press the hardwired switch for start and the hardwired switch for stop is not being pressed, I'll have color there and color there. If no one is pressing the stop switch on the HMI, I will also have color there as well. You get color all the way through. Y1 colors and keeps itself sealed in. So when you let go of that the start push button, and that uncolors, you'll still have a path for virtual power for color to get all the way through and keep the motor running. Similarly, if you were to press the start push button on the HMI, that will color and initiate the latch process, and it will seal itself in. Then to unlatch the motor, to make it stop, all you have to do is either uncolor that or uncolor that. You can uncolor that by pressing the hardwired stop push button, which turns that bit to a 1 and makes that uncolored. Or you could press the HMI push button object, which will set that bit to a 1 state and uncolor that normally closed contact in the PLC. So that is the latching logic inside the PLC to make the motor work. Switching to the HMI, what we have here are a set of virtual push buttons on the screen. We have one for starting the motor, and that is linked to a tag name, push button start. And then we have one for stopping the motor, linked to a tag name, push button stop. If we go to the tag name database, we will see those two tags. So we have push button start, push button stop right here in those two lines. They are going to C1 and C2 bits respectively in the PLC. They are both discrete, and of course these are read and write. So the HMI has the ability to read the status of the C bits as well as to write data to them. And that's how the HMI is able to assert control over the motor. That program has been downloaded to the HMI, the PLC program downloaded to the PLC, so now we have starting and stopping through hardwired push buttons, as well as starting and stopping through the virtual buttons on the HMI.